All right, what we got to do here is determine if this set A union B is infinite or finite. If it's finite, then we need to express the set in roster notation. If it's infinite, then we write infinite in all caps. All right, so remember that A union B is a set of all x such that x is in A or x is in B. And this is really just the set of all x's that satisfy this property. Now remember, what does it mean to be in to satisfy an or? It means that you satisfy one or the other or both of the two statements that are put together. All right, let me give myself a little more room here. All right, so B is an infinite set. So all those things that are in B are also going to be in A union B. Excuse me. And all the things that are in A are also going to be in A union B, right? This is because of the fact that A is a subset of A union B, and the fact that B is a subset of A union B. All right, and so because this is an infinite set, because B is an infinite set, and B is a subset of A union B, right? That means that A union B must be infinite, right? Because you can't have an infinite set be a finite, or you can't have an infinite set be a subset of a finite set. It just doesn't make sense. So it has to be infinite. Now, as I was going to do before, I could write these out and get an idea of what's in there as well. There's nothing wrong with that. But I just wanted to kind of give you the big picture idea here, and that is, right, that B is a subset of A union B. And B is an infinite set. So if you have an infinite subset of a set, then whatever that set is, in this case A union B, has to be infinite. All right, but in any case, we've got -6, -4, -3, -2, 0, 1, 2, 3, 4, 5, 6, 7. Let me write some more of them out here. 8, 10, 12, and so on. Okay, so the answer is infinite. Infinite. Okay, now A intersect B, these are all the things that are common to both. So if you think about it, let's see, what do we have that's common to both? So basically, because, so we're going to look at A now. Looking at A, what are the things that are in A that are also in B? This is 4, or -4, -2, and 0. So you got -4, -2, and 0 there. All right, let me just mention a little something about types. So I'm going to write something incorrect now. This is incorrect because, all right, so yeah, this is not true. Right, it's not true that the intersection is -4, -2, 0. It's true that the intersection is the set containing -4, -2, and 0. Now this sort of thing comes up all the time in computer programming, right? You can't set an int equal to a float. You can't set an integer equal to, I don't know, some other type of object that you create, right? So you've got to have the same type. So in this case, we have same type, set equals set. In this one, we don't have the same type. We have a set equal to a list of integers, not the same thing.